Hello everyone and welcome back to a new tutorial. In this one we are going to create a tic-tac-toe game. It's quite easy and fun to build. I will show you what the game is going to look like when we are done. So small tic-tac-toe game that is working. 2 players, so player 1 and player 2. And as you can see it's a normal tic-tac-toe game. In this case player 1 won the game. You can reset it. We can try to make player 2 win now. Player 1 again, won the game. Let's this time make player 2 win the game. So player 2 wins the game. One more time, player 1 maybe. We can make him. Yeah, player 1 wins the game. In order to reset it, to restart from scratch, from 0, we just press on restart, and then everything is back to square 1. So that's quite fun and yeah, easy to build. But first of all, I would like to start with the game logic. So back here, we are just going to establish the rules of the game, what we are going to need inside, and yeah, just the logic of the game. So I will just start with a class called game. Okay. And inside this class, I'm going to define few static methods. So first method. So first we need a matrix which will hold our players' moves. So this matrix is going to be a list of lists. So a list that contains 3 lists, and each of those 3 lists contains 3 positions or 3 numbers. First we will start with zeros all over the place, and then when player 1 makes its move, we will place 1 inside that grid, that matrix, and when player 2 makes one move, we will exchange the 0 with the 2. So let's first define define a method that gives us a grid or a matrix. So no parameters needed here, and we are just going to return a list of lists. So a list, and inside we are going to populate this list, or each list we are going to populate it with zeros. So we are done. Let's just print this one to see how it looks. So I will just create an instance of the class. And I'm going to rename this properly. Refactor rename. Let's call it game refactor. Okay. And now let's print the grid. So print game matrix. And if we are going to run it, so we have it, a list which contains 3 lists, which each of them contains only zeros inside for now, for this beginning of the game. I'm just going to copy this and put it somewhere up here maybe, so that we can visualize later how this is going to look like. Okay, next we need a way to point our future cells, game cells. So each of these cells, we have to point them to a place in this list of lists. So for example, this game cell is going to be, let's say, named game cell number 1, game cell number 2, game cell number 3, or just 1, 2, 3 up to 9. But then we need a way to connect this number name of the game cell with each position in this list here. So in case of game cell number 1, this is going to point to first position of the first list of this all list. So it's going to be 0, 0. So the easiest way to do that, to connect them together, is to create a dictionary, and then in this dictionary we are going to point position 1 to position 1 in the list, position 2 to position 2 in the list. So let's do that. So we are going to create another static method. I'm just better just do this so we can see it easier. Now it's looking more like a grid from a tic-tac-toe game. So again, static method. And this static method is going to be called position dictionary. Just easy to understand. Spelling. Okay. And we are just going to return here a dictionary. So return a dictionary. So let's make a dictionary out of it. So position 1. So this will be, as we discussed earlier, this will be position 1. So game cell number 1. So position 1 will be pointing to, and here we are going to make a tuple because this is immutable. So 0, 0. Okay. Let's copy this over. We need some spaces here, I think. Yes. And our position 2 is going to point at position 0, 0, 0, 1. Don't need this anymore. Okay. Position 3, it's pointing at 0, 2. Okay, so position 1 pointing at 0, 0. So 0 list, or the first list of the big list, and position 1, this one. 0, 2, again the first list of the big list, position 1. So 0, 1. 3, first list, last position of this list. And we can copy this 2 more times. And now we have position 4. And in this case, it's going to point at position 1, not Q, but 1, 0. Position 5 is going to point at 1, 1. Position 6, 6, 6, not 6 is 1, 2. Okay, position 7, 2, 0, position 8, and position 9. After we are done writing these methods, we are going to write a small test code so that we can see that this is properly working. Okay, the next thing that we have to do is to create the game rules or the game logic so that we know when the game has ended. So for example, if one player has covered the entire line, either horizontally or vertically, or if one player has one diagonal filled with his symbols, then the game has ended and that player has won. Or the game can also be finished, or game can be over when we have a tie. There is no all the cells are covered, but there is no winner. So let's try to think of that logic, how we can build that logic. So we need to check after each move if one player placed his symbol on 3 times in a line. Doesn't matter, it's a horizontal, vertical, or on diagonal. So we need to check each vertical line if the number inserted match. So if one player, so for example, we said that player 1 is going to insert 1 and player 2 is going to insert 2 in this matrix here. So we can see this here as well. So if all of the values in this list here match and they are different than 0, so they can be 1 or 2. If they match, then one of the players won. If all this first, second or third, but in a vertical row, if they match as well and they are not 0, again the game is won. Same goes with the diagonals. So this one is this one. So in this case we have 1, 2, 3, 4, 5, 6 cases, 7 and 8 plus the diagonals. So let's write a method that covers that situation. So this is going to be again a static method. So and we're just going to name it game status. In this case, we do need to pass into this function the game matrix. So this game matrix, every time we have to pass in this game matrix. So we're just going to call this just game. We need to check every time what's going on with the matrix. Okay. So first let's check if all these values here are the same. And if they are the same, we have to return who won the game. So if, and now remember this is a list of lists. So if game, and we are pointing first at this list and these objects one by one. So if game 0, 0, so we are pointing now at this one. The first object is equal to game, and now we need the second one, 0 and 1, and it is equal to game zero 2. So 0 2. So if this one is equal to this one and is equal to this one, and they all must not be equal to 0. So if that is the case, we need to return who's the winner. And how we can find out who is the winner. So we said that if we have, for example, all we have number 1 entered 3 times, so player number 1 entered his symbol 3 times in this row, then he wins. Okay, so then we can check like that. Return. So in case player 1 wins, return. Let's return X because he's player 1. If, and now we're just going to check if game 0 0 is equal to 1. So in case, because now we know if they are all equal and they are not 0, then we can just check only 1. If this one is equal to 1, you return X. Else, we return O. And now we have the first case covered. Now we have to enter this 7 more times. So I'll just else if. I'll just copy this because it's the same. And in this case we need 1 0, and now it's pretty easy for this. 1 1. And the case here are the same, exactly the same. The only thing that we have to check if this one is equal to 1. And so time, and here 2 0 2 1 2 2. Okay, 0 if game 2 0. So if in case this one is equal to others. So now we covered all cases when the game is won by horizontal line. So this is this one is this one, and this one is this one. Now we have to cover the cases when the game can be won by a vertical line. else if. So let's copy it again from here maybe. Okay, and let's look now. So now we are looking here. So 0 0 is correct. Now 1 1 should be the next one, because this is the one, and then sorry, this should be 1 0, because otherwise we are going to diagonal 1 0 and 2 0. Okay, and now if 0 0 is equal, then okay, so now we have covered this vertical line. Now second one, let's copy this one and modify it a bit. So else if, and now we have 0 and 1. So 0 1 is this one, then 1 1, which is 1 1 is this one, and then 2 1, 1, and then here 2, and inside here again we are looking for 0 and 1. We are checking if this is 1, else okay. So now we have covered this one. Going for the third one, let's copy this. So we have here 0 and 2 is the last one in the first list. 1 and 2, and 2 2, this is correct here, 2 2. And here we are looking for 0 2, 0 and 2 for being 1. That's perfectly correct. All we need to do now is to get also the two diagonals, and we are done. So let's copy it again. Let's make a bit of space here just to see it. And we are looking for 0 0, 0 0, and then we are looking for 1 1, because this is 1 1, and this is will be the same here, 1 1, because both diagonals have the same in the middle. And then 2 2, that's 2 that's correct, 2 2. X 0 0 here. Okay, and in this case we are looking at this is 0 2, that's 0 2, 1 1, and here is 2 0. So 2 and 0, 2 and 0, that's correct. Okay, and here 0 2, if it's 1, that's also correct. Okay, so now we have all our rules to spot if the game is won and by whom it has been won. The next thing that we also have to do inside this function is to check if the game is a tie or not. So in case there are no more places to place 1 or 2, then the game is a tie. So if the game is checked and none of these if statements catches the condition, then we need to check if we still have some zeros inside our game matrix. So to do that, we can just loop and search for a 0 inside the game. So for I in game, okay, if 0 in I, return game on. So for each list in the list of lists, for each one, we are checking each element of the list, and if we have a 0 inside one of them, we return that the game is still being played. And if that is the case, we return that. If not, we can return game over. That's the logic of our game. There is one last function that I would like to implement here in this game logic, and that is in case, for example, the game went up to the last move, and it's clear that player 1 is going to make the next move, and when he clicks it, he's going to win it. So it's just a bit of extra automatization of the game. So let's go ahead and write that function as well. So here underneath this function, I'm going to call this one check for tie. I don't know if the check for tie is the correct name for this function, but let's just call it like that. And in this case, we are going to need few things. So we are going to need the game matrix and who is going to do the next move. So we'll just game. So this is the matrix, and then next move, or better next player. Okay. So first we are going to check how many available moves we still have. So this is going to work only when we have only one move left. So we are going to define as available moves, set it to 0 for now, and then we are going to check if there are one move or more left. Game status. Okay, available moves. Now let's loop through the game and see if we have more than one moves. So for I in game, for each list in the list of lists, and for j in I, for each element in each list, if j equals 0. So if we have a list, then available, we will increment available moves by 1. And now, once that is done, if available moves is greater than 1, then we return false. Return false. Else if available is equal to 1. Okay, so if it's, I will make this one smaller. So if it's equal to 1, we need to know exactly which of those numbers is 0, so we can go further with our intent here. So we have to go loop again. So for in range 3, so now we are just looking for the one entry with 0. So if game position I j is equal to 0, then we just make this position next move. Next player. So we just enter in our matrix in the found position, in the found remaining 0 position, we enter the next player number. So in case it's player number 1, we are going to enter 1. In case it's player number 2, we are going to enter number 2. And then we are just going to check if that is going to make the game a winner game, or if that is going to be a tie game. So here we are just going to return true if self dot game status, and then we have to pass in the game yeah, is equal to game over. Else false. And now you can see here, okay, I have made a typo here, so factor rename available moves, that's correct. Okay, now we can see here the difference between a static method and a normal method inside this class. So in this case we have mentioned the instance of the class because we have to modify the grid of that specific instance. The easiest way to spot a static method is if you do not see self inside, or you do not need self inside that method, that means that is a static method. But of course you can check more about that on online in the Python documentation. Okay, so now we have completed our backend of the game, and I would like to carry out a bit of testing for that, just to see that everything is running before we start to build the graphical part of the game. Okay, for the next part we just need another Python file, so new Python file, and let's just call this one game tester or engine tester. Okay, so we need to use this logic that we have here inside the engine tester. In this case we have to import it, so from game backend import game, and let's create an instance of that, so game equal to game. Okay, and we need now two players, so player 1, and let's assign 1 to player 1, and then player 2 will assign 2. Okay, and what we need next is to have a game matrix, so game matrix, and we are going to get it from the game instance. Okay, then we need the position dictionary, so game position will be equal to game position dictionary. Okay, so we have that as well. Okay, next we will need a function that is going to print out on the screen the matrix, so it will be easier for us to play in this non-graphical user interface part of the testing part. So definition print game, and here we need a game matrix, so G matrix to be printed. Okay, so we're going to use here f strings. Okay, okay, so we need 3 lines with 3 lines, 3 columns. So we need game matrix, but we need it game matrix of position 0, 0. Okay, let's just copy this. Two more time, 0, 1, 0, 2. and in between we need a pipe character just to split them up here as well. Okay, and let's copy that. Here a new line. Okay, and in between we also need some spacings, so it's a bit too much maybe. Here again, spacing. Okay, and we have here 0, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, and 2, 2. Okay, so this function is printing us our grid, and now let's build just a while loop, a continuous while loop. Okay, while true, and then let's just ask the first player to insert one of his choices. So let's say player, let's just say played input. Once player 1 enters a number, we need to unpack the tuple that that number represents. So for example, here, if he entered number 1 or number 2 in this case, we need to unpack this tuple in the x and y. So let's do that. So x, y, and here is game position. Game position of played. Okay, let's make this, let's see, we can see it better on split screen. Okay, so once he enters 1 or 2 or 3, we are just going to pick from this dictionary the value of that key. So for example, if he chooses value 6, we are going to unpack this tuple in x being 1 and y being 2, and then we are going to use this position inside our grid. What we need to do also is to see if the same position was not already played. So to do that, we need a list that we can define here in the beginning. So played positions, just an empty list. Now we can check if the position that the player played is in the list or not, and if it's not in the list, we are going to place it in the grid. Played not in played positions. So if we do not have it in the play position, then game matrix x and y is equal to player. So we are going to place in this game matrix at position x, y, whatever the number of the player. And then we have to append this to the played position. So played, append, append played. And then once we are done, we can print the game matrix. so that the next player can see what move to make. Now that the player one made placed a number in the matrix, we have to check if he won. Okay, so we just have to say if game status, and here we need to place the game matrix. So we are going to check this matrix for not equal to game on. We are passing the game matrix to this function, and we check if we do not receive game on. So if the if condition was caught somewhere here, then that it means that the game is over, so we can break here. Otherwise, if we have game on, we can still go on. So here, break. Else, we go to player number 2. So this will be the same. Played, player number 2, please enter a number, game matrix. Again, we have to check if played not in played positions, and then game matrix position xy is equal to player 2, and then we have to append this position to the list, so we don't play it again. And then of course we print again the grid, so we print the grid, and then again we have to check if we have if we finish the game or not. So again we are doing the same thing again here. We are checking the game status. So that looks good. I think we are done. Let's try to run this one. So run. Okay. Let me stop it for once, and then I think I forgot here print statement. Yeah. This we can delete for now. Okay, let's try it again. I will make it a bit bigger to see. So run. Okay. Player 1, please enter a number. So I'm going to enter 1, and I'm aiming for this position. Okay, something is wrong here. It should have been separate by new line. Maybe I'm printing something wrong. Okay, of course, that's why. We need to print game, not print, only print. Print game. Okay, one more time. Start. Enter number 1. And okay, now it's better. It's a bit too long. Stop it for now. So these lines are a bit too much. Okay, let's try it again. Okay, player 1 plays 1. Okay, so, okay, now it's looking a bit better. Maybe we just need one more minus here, just to be perfect. Okay, so player 1 played position on. Okay, player 2, I'm just going to play position 5 here. And something is wrong. Okay, I think here I made a mistake. It should be here. Okay, let's try again. Stop, start, enter a number. Let's aim for 1 again. 1, player 2 aims for 5. No, still wrong. Something is wrong. Okay, I forgot to assign or to unpack the tuple. So I need to unpack it here. Okay, let's try again. Player 1 makes 1, player 2 makes 5. Now it's better, of course. Player 1, 1, player 2, 5. Okay, player 1 is going to make 2, and I have 1-1, and player 2 is in 5. Okay, player 2 makes 6. So 1-1, 2-2, and let's try to win by player 1. And I made a mistake because I pressed 1, and that move was not approved because it was already in the list. So let's try to win now by player 2. So I just need to press in 4, and the program finished, because as you can see we have 3 in our line here and we won. Let's try again, and let's make another line win, but a vertical line win. So player 1 plays 1, 2 plays, let's see, again 5, then player 1 plays 4, let's make it in a line, 4, and then player 2 plays 6. Okay, and then player 1 plays that should be 7, and yes, we have again a winning situation. Player 1 won by the first line, vertical line. Okay, let's try again on a diagonal, or let's try now to win by player 2. So player 1 makes 2 and 3. Okay, now player 2 makes 1, player 1 makes, let's see, 3, and now we are aiming for the diagonal. Yes, player 2 makes middle of the matrix, 5. Okay, player 1 makes 7. Okay, and now we just should aim for this one. So player 2 aims for 9, and we broke it because I enter something that was. That's a good point. You can try to better this code and avoid these situations, but only for the testing purposes here, I'm just going to keep it like that. So, but for you, of course, you can try it. For example, if the player enters a letter, you can avoid that. Tell the player, okay, you entered a wrong. You should enter numbers from 1 to 9. Don't use, for example, lowercase letters. Don't use uppercase letters. You can improve it as you like. But okay, we just test it here, and I'm not going to improve it too much. So let's try it again. Diagonal, I said, with player 2 winning. So player 2 makes a move, player 1 makes a move 2. Okay, player 2 makes a move in 1. Okay, player 1 goes again with 3. Player 2 5 in the middle. Yes, player 1 7. Okay, and now player 2 9, and it's okay. Yes, the game is won by player 2 having this diagonal covered. Okay guys, so now that we know that the game is or the back end of the game is working, in the next part we can focus on the graphics. So that's all for now. Thank you very much for your time. I wish you all the best, and see you in the next one. Bye.